My name is Christian Brinker.
And my name is Martino. Hi.
And we are presenting you about the Open Service Broker API. So what is the Open Service Broker API? The Open Service Broker API is an open standard to organize service offerings for cloud-native platforms. It was first developed by the Cloud Foundry community, later on extended to support other platforms, for example, Kubernetes. It is an open standard. For more information after this talk, you can visit the project's website and the spec ref on GitHub. You can find the URLs on the slide. The idea behind the Open Service Broker API is to create a standardized API spec around the lifecycle management of third-party services for a developer's application. So, why should I use the Open Service Broker API? Let's face the problems. I'm Bob, and I have this cool application in my head I want to code. What helps Cloud Foundry with this app is it delivers me with an environment to develop my app for different stagings, like a development stage, like a production stage, and presents me with this cool CF push experience to help me push my application really fast into production. It helps me with scaling my application and also with routing, DNS resolution, or certificate management for TLS. But what it doesn't help me with is backing services like databases, or even other stuff like opening specific ports in a firewall on demand, message queuing, special configurations in a load balancer appliance, adding TLS certificates for a domain in the TLS chain for the app, auto-scaling capabilities, forwarding of log drains, and what you can think of. All the stuff which is not directly part of Cloud Foundry. So what is the problem? We have this application which needs this service which is not part of Cloud Foundry and needs to access it. And Cloud Foundry does not know how to do that. So, for example, I have a web app and want to use a MySQL database which runs on an IaaS vendor like VMware vSphere. So, how do we solve it in Cloud Foundry? So, I'm the developer and I go to Cloud Foundry and say, hey, Cloud Foundry, can I have a service instance? Then the Cloud Controller, which is part of the Cloud Foundry installation, knows someone which knows how to create this service instance, which is the service broker. The service broker creates the service and creates also credentials, which it presents back to the Cloud Controller, which adds them to the application's runtime as environment variables. So the application can access the service directly. And this whole workflow is defined by the Open Service Broker API spec. So this is what the Open Service Broker API is about.
So let's now focus on the marketplace and the service catalog. As a Cloud Foundry user, you will typically ask the platform to show you the marketplace. And so the marketplace is where all services and service plan are shown and registered by the service broker. The plan describes the potential service offering and gives information about the size of the service instance that are being deploying, or custom settings like CPU, RAM, and disks, always depending on the service. And you can have always more than one service plan per service, and you can always have more than one service that is registered by the service broker. So in the context of the service broker API, everything is deployed as a service, but we also want to have like a separation between services. So we have, for example, managed service and user-provided service. Managed service are services that are provisioned and managed by the platform, while user-provided services are services that are provisioned by the user itself to the platform. And for example, I know that I have an external log drain for my application, and I just want to bind that external log drain to my application. So there is here no interaction with the service broker. We also have another class of services called bindable and non-bindable services. By bindable services, the application gets the credentials to access the service through the bind operation. And by non-bindable services, the application doesn't need to be bounded to the service. So we just so that the service is just being created. You can think about it like, for example, where you have to generate TLS certificates for a domain. Another class of services are root services. And here is like, introducing a man in the middle of a root in Cloud Foundry so that the requests are presented to the backing service first, and then just later on forwarded to the application. We also have syslog drain services where the platform will stream the log to for the bound application. And we have volume services. It's like, a particular service offering that provide network storage for application into the application container. So let's jump into the life cycle of creating and using the service broker. We typically have the command cf create service broker, and where we have seen that the cloud controller will fetch the catalog of the service broker to validate the catalog and to see if the catalog respects the JSON schema API that is specified in the OSP API spec, and then to show what are registered in the platform and what can I provision in the platform, what can I create. I will use the cf marketplace command, and then I will use cf create service to just provision an instance of my service. And then I will use the cf bind service command to create the binding with my application, or unbind service to delete the binding. And then in the end to remove the instance, I will just type in the cf delete service. And every step that we see here will produce a REST API call to the service broker. So when you're deploying a service broker, you have to make sure that the service broker exposes these endpoints, and all these endpoints, you can find all these endpoints that are specified in the Open Service Broker API specs. And there are synchronous or asynchronous endpoints that can be registered depending on which type of services you are deploying to the platform. And there are also some optional services, for example, for non-bindable services that do not require the service binding endpoint. And what we have seen when we're talking about service plan and services, we know this can mean various different things. For example, when we talk about the database service plan, it could be just like creating a database in an existing pre-provisioned cluster, or creating a single dedicated VM for my database instance, or when probably running in production, you will probably have to create a new cluster of VMs and make maybe some custom setup configuration. And all these things comes with services and service plans. So we have seen so far that through the binding operation, the application gets credentialed to access the provisioned instance. But what about accessing the instance without an application, or just handling credentials without a binding to an application? So we have seen that the user will type in the comments, and the cloud controller will talk to the service broker, and the service broker will create a service, and then the service will get through the cloud controller, being back to the application. But with service key, we will have just no interaction with the application in the life cycle, so that the service will be created by the service broker, and will just it will just get him back to the user and in that case the user can just access the service without having deployed an application. So the only difference when talking about service keys is just like we have custom commands for creating and deleting service key, and the service broker will just create a normal binding and make it available for the user in order to connect to the backing service.
So we talked about the lifecycle, which is organized by the service broker, and how cool the Open Service Broker API spec is. But what are the pitfalls, the ugly truth moments when creating a service broker? Service broker creation can be really hard. When you think about the special things which come with providing services. So how about organizing changes of a plan? So if, for example, you started with an existing cluster where you provisioned databases inside of, then the user wants to switch to a single instance or a personal cluster. So how do you organize these changes of plans? The Service Broker API spec helps you with providing update endpoints where you can handle these things through the Open Service Broker API spec. So the platform can offer this to the users, but what has to be done in the background, you have to organize inside the service broker. And that can be really hard and tough stuff. Also, when modeling the service catalog, what do you make a service? What should be a service plan can be really hard choices. Also, how do you do monitoring of provisioned services? How do you organize configuration management of these services? And so on and so on. How about with multi-tenancy? How do you organize user management in a shared existing cluster or in personal clusters? How do you organize, what is this credential you provide to the user? How do you also cope with this in the context of multi-cloud? What are capacity bounds? This makes a difference if you're in an existing cluster versus in a personal cluster. So if you have a database in an existing cluster, each database should be bound to specific resources which are should be made available. For example, if you have a plan with 30 gigabyte of space of disk, you shouldn't be getting around that. Session management, backup management, version updates of services in case of CVEs of these services should also be handled by the service broker. And don't forget about tests. Yeah, your service broker is a piece of software which should also. So you should also have tests around implementing the Open Service Broker API spec correctly. For this, we have developed the OSB checker, which helps you developing the service broker as a contract tests suite. You can find the link here. Also, you should provide external smoke tests to test if the service which is created by the service broker is provisioned the way you want to. And you also should battle-proof test your services which you create. So, service broker is a fun topic to think about. It is really helpful for your developers to have a service broker at hand, and but it comes with some problematic points. First of all, we want to thank you for your attention. Have fun at the rest of the summit. If you go down the road with the service brokers, go back to the slides, look at the links for the project's page, and also you can contact us. We have a broad knowledge about developing service brokers and service broker framework to ease the steps of the lifecycle so you don't have to re-implement all the stuff. Also, I made a talk at the last year's North America Summit about writing your first service broker and what you have to look up and do in this type and what you have to implement. And there are also videos out there about our service broker framework. You can find all these videos on YouTube, or if you struggle to find them, please contact us. And like I said, have fun with the rest of the summit.
Have fun. Bye.
Hi, Onno. Can you hear us? To your question from before, I think there are two things. First of all, you can edit. Thank you for. Yeah, it's really confusing with the extra session. So with your question, towards the CF on Kubernetes, the Open Service Broker on Kubernetes and on CF. On CF, you update the service broker, all fine. Then you have the service broker in CF with on Kubernetes. You need to install in your cluster the service catalog. It's an open source project you can download, and then you can add the service into the service catalog. Towards updating a service, if you deploy VMs in background to the service broker, I think the easiest way to do updates, for example, if you deploy with Bosch in background, you make, or if you, it's about your what is your service for clarification? Is it an app or is it some VMs you're starting in the background? If it's some VMs you have, for example, deployed with want to broker to run Kubernetes for Kubernetes, no dependency on CF. Okay. A database. Okay. For example, you have your service broker is an app. You deploy it on CF and so on. You know that. And in the background, it, for example, deploys a VM with a database. If you switch over to Kubernetes, you have to deploy the service broker in Kubernetes. So you have to make a deployment for that. You add it to the service catalog. And then in the background, it either deploys VMs like before. So there's no change in the service broker at that part. So you have to have a wash director or something for the database deployment or whatever you use as a technique to deploy or manage the database. Or if you change that on the switch to Kubernetes, you then have to deploy something to Kubernetes. For example, you use a Kubernetes operator framework and then manage the operator. For example, running a Helm chart to Kubernetes, which then deploys using the CRDs from the operator. It may be the same code, but does not have. If you change something from your perspective, what the service broker should do, so you have to shift. For example, you want to also to deploy the database on top of Kubernetes instead of VMs, then you have to change something. But if you still want to do the old stuff with deploying the VM, you're fine to go. You can use the same code because the service catalog or Cloud Foundry only uses the open service broker API as an API spec, so it doesn't not know what is going on in the background. No, the CF update functionality should also be there because the service broker can that, and I think the service catalog from I think service catalog should be equivalent in functionality. There should be an update functionality, but I'm not sure. I have to look into it. Wait, I think service catalog was equivalent there. Service catalog, so update. If it does not, documentation. Wait, resource provision new, binding, potential mapping. I have to admit, I cannot find it on the first view, but it should be somewhere here. I hope that helps, Ono. With the Florian, with the communication direction CF API talks to brokers, stay, or do you always consider change to an approach where the service? Okay, similar. I'm not sure. To Florian, to your question, I'm not sure. I think that will not change because the communication direction there is really strict. I also think that the possibility to re-update stuff from the catalog would be also fun, but I don't think that it's coming in the near runtime, because that's a topic which is talked about in the community a long time, and I don't think there is changing much from the communication perspective, because you not only have to to change the Open Service Broker API spec there, because the catalog exchange has to change, for example, and other stuff. You have to have a direct communication to the controller. So the service broker for the first time is able to log into the controller to add stuff if you change the communication direction and such on. So I don't think that, yeah, a new API version for sure. Maybe in future versions, you can participate in that. The discussions about adding new features in the Service Broker API is a talkative topic. The community there is open. So you can propose that to the new spec. You can by raising an issue on the GitHub repository, and the discussions about these topics is also in open sessions on a regular basis. So you can join and discuss live around that with the others. Ono, if you want to, if it's the first time for you to develop such a service broker, we developed quite some and also made a framework around that. It's not yet able to deploy Kubernetes operators, but you can easily add that. We plan to do that, for example. So we can deploy Kubernetes operators out of the framework. So you don't have to implement all the stuff. I made a talk about that in last year's North America Summit. The video should be online, where I talk also about if you start writing your first service broker, what are all the stuff you have to do. It's some overlap with the talk now, and also I shared their link to the GitHub repository of the framework. We made quite some documentation about which part of the software is used for what, and it's on. Okay, yeah. Using pack should be easy running stuff on Kubernetes. Yeah. The hard part is running databases on Kubernetes, but therefore the operator community is helping us from the other side, so we have only to tackle from our side there. I hope so. Did I miss some questions? Let's scroll back. To Mauricio, I'm not sure if there is a complete repository with a complete stack only for Kubernetes. I have to think about if I know something. I know, for example, I wrote that in the chat in the original talk. There is KSM nowadays, Tanzu Service Manager, which tries to deploy arbitrary operators, but it does not know about the specialties of that operator you put in there. So it's more like a start button to deploy Helm charts. And there are operator frameworks or Helm charts you can deploy with that. But I don't think there is a service broker yet with the whole stuff around, which is open source and available. I know that people work around that. We do too. But I'm not sure if there is a complete version online available. I don't know. Yeah, they are recorded perfectly. So, any questions we didn't answer? Any new questions? Any details? Great. Any wishes? Do you want to know something? With operators, yeah. Yeah, I think so. Definitely. Definitely, because there's a strong need. If we move with Cloud Foundry to Kubernetes, having Bosch deployed databases seems like a little bit awkward. And because then the Bosch directory is deployed for the service broker. Beforehand, we had brokers around, Bosch directors around, which we can use, and all the people know Bosch. But I think we will go into the next phase when people switched over. We will have operators which are Kubernetes native then and never touched a Bosch director, and then for the service broker need to deploy for the first time a Bosch director and get to know with Bosch and so on. And I hope we can circumvent that by moving stuff to Kubernetes. I mean, there is some drawbacks if you move with the database from VMs to Kubernetes. Not all databases come in there very handy, but most database producing companies nowadays switch to containerized deployment. And with that, the databases get hardened and be able to deploy to Kubernetes. Most of them also started to develop operators themselves. So I think that's only a matter of time if that gets the golden standard. And from that time on, we get the real cool whole picture. Data data services and apps deployed on Kubernetes through Cloud Foundry. That's the main goal, I think. Are there any questions in the Q&A? If there are tips for best practice into using Go routines for handling async, it seems to be imperfect. Yeah. For example, what we did, our framework is on Enno's question for one in the Q&A. I think if there are tips for best practices, I think first of all, if you develop a service broker, don't implement all the API stuff. Choose one of the frameworks around for start. There's something in Spring Boot. We switched, we diverted with our framework a little time back, so our service brokers are in Java apps. Because we, if you dug deep into the service broker API and managing services in the background, you get to know that the routines behind the API spec, if you want to make them really good, some a little bit hard. For example, the other async parts and so on. And you have to have a data store in behind to or something like that to know which service instances you managed, in which state, how you deployed them, if you update them, what to do, because service update can a little bit really, really tricky thing. Because if you deployed a VM deployment, a clustered deployment, what do you do if you want to increase the size? Is decrease an option for you when updating? How do you manage version upgrades? For example, if you want to make a patch or a major version update of the service, do you provide a way to back up the database and deploy a new service instance and put in the backup, or what do you do with that? So that's a really bit problematic at that point, what to do. There's no golden standard, I think, out there. but don't make it too nasty for the developers. So what you aim for is a high standard on automation. So patching, for example, means update to the next version as a parameter of something. And you don't want to implement all the general management of such parameters, handing over and so on. So the frameworks help you with that. I mean, we started our framework in 2015. Yeah, was quite right since then. And you don't want to do all the stuff on yourself if the spec updates and you don't want, and you have to update your service broker. You don't want to have problems then with interjoined services. And if you have two service brokers, you have to put in then the new spec parts in both service brokers. So using frameworks, they're really helpful. What's also golden standard with that is don't aim for designing the service broker. Aim for designing the service broker provides. So if you start developing a service broker, don't think about the service broker first. Think about the service you want to create. So in terms of what is that the user needs. The user says, I need a MySQL database. But what that means in terms of high availability, fastness of availability after the provisioning, size, backup functionalities, support hotlines, pacing of the database after creation. So, for example, adding some routines and so on. What is that? What you want to provide? Only if you know that, you know what the service broker should do. Creating a database with a Helm chart of something is really easy, but then you have a mess when it comes to day 2 operations or adding helpful functionalities for the developers. And the CF is about the developers. So the services should also be. But if you don't do that, you get a mess, and that's what I think is also the main difference between CF and Kubernetes is Kubernetes is a cool infrastructure orchestration tool for orchestrating containers, but it lacks with user experience. For a developer, it's not interesting because there's so many things to do, so much YAML stuff, and with CF push, you have that easy, and you only with service brokers you want to have that feeling also. So the service you should like you develop an application, so you don't think about the coding first. You think about what is the product I want to develop there. And so that's also the thing you should do with the service broker. That's best practice per se. The golden thing you should do. So. The other thing, any tips on handling the edge cases? Is there some kind of test drive app I can use to exercise service brokers? There are two things at the moment, I think. The first of all, contract testing. We have, for example, developed the OSB checker, which is also linked on the BAPI page. That's a cool thing because if you develop service broker, you're not sure, did I implement the spec correctly? With it all, that's tiny edge cases and so on in the spec, which are not that maybe really good documented. So it springs into the eye, oh, I should have to implement that. So the OSB checker is in contract testing tools to test if a service broker implements the Open Service Broker API spec perfectly. What it doesn't do is test the service in the background. And like I said, developing a service broker means developing the service you want to provide to your customers. So high availability, you have to test high availability, for example, your PostgreSQL setup in the background. So you have to have something like chaos tests or something in your CI/CD pipeline for the service broker. So if you change something in the deployment you run, the operator, Kubernetes operator you run, the BOSH deployment you use, you have, for example, you put a new version of PostgreSQL in the BOSH release, you have to have some stuff around that. And we had the interesting, started an interesting a little bit scientific project in our company about that. Made some infrastructure tool, which was mainly the baseline out of we have from a master thesis we offered to a master student in a university, and we who had to develop an infra chaos test toolage for infrastructure tests, so we could test the BOSH releases we deployed out of our service brokers, so that we can say if the run of the pipeline of a service broker was correctly run through. We also tested infrastructure tests in that. The implementations we have until now are really specific to some stuff. It's under it's under development at the moment, the toolage. But I think that's something we have to come up also in the community. Like we have service broker frameworks and we have contract testing toolage. We also have to have toolage test tool suites, which tests for the deployed infrastructure. Any questions left? Then thank you and have a nice day.
Have a nice day.